Welcome back to the course of chemical crystallography. This is a second tutorial after the end of second week. So in the tutorial sheet you must have received some problems, so we will try to see how those problems can be solved. So what we have asked is that show that S2 is equivalent to I is equivalent to 1 bar. To show that what is S2, we should first draw a circle. And then if I draw one open circle, inside the circle it is my object, and S2 means rotation followed by reflection. So if I rotate by 180 degree and then reflect, the open circle becomes the closed circle. So this is S2. What is I? I is inversion. So if I have this object and if I invert against the center of inversion, whatever is above the plane should go to the below the plane and become the closed circle. So open circle becomes a closed circle here. So this indicates that this represents I. In the same manner, if I try to draw 1 bar, what is 1 bar? 1 bar is 360 degree rotation followed by inversion. So 360 degree rotation brings the open circle from the point where we started by doing 360 degree rotation, and inversion takes it to the lower hemisphere. So again it becomes the same representation as we have seen for S2 and I. So these are equivalent. So this is how you should solve these problems by drawing the projection. So I am not going to solve the second one for you. I leave it to you to find the answer. The second question in this assignment is asking you to draw some stereographic projections, some of which we probably have drawn during our regular class. So today I will not draw all of them, but I will draw a few of them, maybe 2 or 3. So let us see what happens when it is 2, 2, 2. First we draw a circle, and for our easy understanding we divide it into 4 parts and then put one open circle which represents my object. So now if I have a twofold passing through the center, that means perpendicular to the plane of projection, then this open circle should remain as open circle because it stays in the upper hemisphere, because this is a twofold. The object is here, it rotates like this and still stays in the upper hemisphere. Then if I apply a twofold which is on the equatorial plane or on the equator like that, then immediately what we would get is the open circle becomes a closed circle, and this open circle on the other side becomes a closed circle. As a result, one can observe that the central line that we had drawn earlier, that central line also represents another twofold where these 2 points are rotated by 180 degree. So this particular figure represents the 2, 2, 2 space group. Let us see how it should be in case of six by m. As soon as we see that it is a six-fold, we should draw 3 lines at 120 degree so that we make these 6 parts, and we assume that the six-fold axis is perpendicular to the plane of projection, and then we start with open circle. When it is six-fold, so at every 60 degree rotation you should have one open circle. When it is by M, it means that the equatorial plane or the equator is your mirror plane, which is the circumference of this circle, which I am making it bold. So the circumference of the circle becoming the mirror plane, the open circle becomes closed circle and comes in the middle of the closed circle, middle of the open circle, and becomes like this. Now when we have two mirrors, these two mirrors are now parallel to the six-fold axis, and we can assume one of these lines to start with as mirror planes. So I am drawing the mirror plane using a different color. So if this line is a mirror plane, then the points should be reflected on either side of this plane. I hope this is clear, because when we have one mirror, it actually reflects all the points from one side to other. So the mirror images are now drawn, and I am marking them who is mirror image of what. These two are mirror images, these two are mirror images, here these two, and again these. Simultaneously we can easily see that these ones are also mirror images. We don't need to draw any further mirror, though we write a separate mirror like that, because we can see by observation that the lines which we had drawn earlier are also representing mirror planes. And also in between, these mirrors have been generated as well. So this is the diagram of 6 by M. I will only draw the other 6 bar for 6 bar M2, because it again may be difficult to imagine or understand. As usual, we first draw the circle and divide it into 6 parts. We take the 6 bar axis perpendicular to the plane of projection and do it appropriately, that the central zone is open circle and outer zone is a closed circle, because it is a 6 bar axis. What is 6 bar? 6 bar means it is rotation followed by inversion. So if we start at one point with open circle, we rotate it by 60 degree, that brings a 6-fold, but then we have to do inversion, it should become a closed circle. Rotate it by 60 degree and then do one inversion, it should become an open circle. Rotate it by 60 degree, take an inversion, becomes that. Again rotate by 60 degree, take the inversion, so the closed circle remains closed circle, then on inversion becomes open circle, then open circle rotated by 60 degree and then inverted becomes the closed circle. So what we have done is now just the 6 bar. Now we need to do M. If we take this plane as the mirror, then what we would get are these points. Which actually indicates that the other lines which are drawn are also corresponding mirror planes. And if you observe carefully, what you can find is that the two-fold is already generated along those three mirrors. So this is the stereographic projection of 6 bar M2. I leave other point groups for you to draw yourself, and you should check the correctness with the answers that will be given at a later stage. Now comes a question which has little more involvement to identify the space groups and classify them as different types of space groups. So the question is, among the following space groups, identify centrosymmetric, non-centrosymmetric, chiral and achiral space groups. So we should first write 4 classes. Centrosymmetric, non-centrosymmetric, chiral and achiral. So from these space groups, we can find out whether we have the center of inversion or not. For example, if we see P1 bar, 1 bar means it has inversion center. So P1 bar is the centrosymmetric space group. Similarly, you know that 2 by m, here also it is 2 by m, these are centrosymmetric space groups. We can write as P2 by m and P21 by c are centrosymmetric space groups. This 6 by m, this one is 4 by mm, where I am talking about the corresponding point groups, are also centrosymmetric. Then we have PBCA, which is MMM point group, P4 by m. So PBCA, P4 by m, these are centrosymmetric space groups. So as immediately it is clear that the remaining are non-centrosymmetric space groups, so we should classify them as non-centrosymmetric. See, I43D is M43M, it is not a centrosymmetric space group. So these are P41 and P2121 are non-centrosymmetric space groups. So now among them, which are chiral and which are not chiral? Of course, all centrosymmetric space groups are achiral space groups, no doubt about it. Plus, the space groups which are non-centrosymmetric but contain a mirror plane like PM, PC, I4 bar 3D, FDD2, PNA21, these are achiral space groups. So we can write those as well along with the centrosymmetric space groups PM, PC, I4 bar 3D, FDD2, PNA21. These are non-centrosymmetric but achiral space group, simply because these have at least a mirror or a glide plane. The planes, the space groups which do not have any mirror plane in them, those space groups are called the chiral space groups. So the chiral space groups are here P1, C2, R3, P23, P32, P41 and P2121. So one can conclude from here that all chiral space groups are non-centrosymmetric, but not all non-centrosymmetric space groups are chiral. A part of non-centrosymmetric space groups which contain a mirror plane are achiral, and also one can say that all centrosymmetric space groups are achiral. A centrosymmetric space group cannot be a chiral space group. Why? Because a chiral compound, a pure enantiomer, cannot have its mirror image crystallized together in the crystal structure. If a chiral compound crystallizes in a structure, it always goes in chiral space group and do not have its mirror image in the structure. If a racemic mixture crystallizes, it can crystallize in centrosymmetric or in non-centrosymmetric space group, but it has to crystallize in any of those achiral space groups. It may be a centrosymmetric space group or it may be a non-centrosymmetric but achiral space group. So this is how one should understand the space groups which are possible for a chiral compound and which are possible for a racemic mixture.